Hi, in this video of import, we are going to be starting with, or rather I should say continuing with the applications of higher order differentiation. So let's get straight into it. Now, this is another question that has been asked in your previous years. You were given a utility function which is of the following form. Q1 minus gamma 1, Q2 minus gamma 2 are your, they're in the brackets, and you have a log attached to it, and you have beta 1s and beta 2s. Now I understand that this function, if for somebody who's a little scared of mathematical symbols, this may seem like a very daunting function to just look at, but in life it's a very, very simple question. It's quite possibly one of the easiest questions I have seen asked from this unit, and more importantly, there is no very high levels of computation required. It is just simple differentiation, and you should be able to get done with the question. Now, one of the things that is important to sort of look at when you're reading this question is to understand what the conditions on the constants are. So, for example, here you can see that beta I is between 0 and 1. You know that gamma I is greater than 0. You know that qi minus gamma I has to be greater than 0. Naturally, for the function to itself be defined, because the log is only defined on the positive numbers, r plus, and I is between 1 and 2. So that's fine. The first part of this question says find the marginal utility with respect to Q1 and determine its sign. So you just do a del U by del Q1, which in this case is going to be precisely equal to beta 1 into 1 upon Q1 minus gamma 1 into 1, because chain rule. Now you know that beta 1 is greater than 0, and you know that Q1 minus gamma 1 is greater than 0, which means that delta U by delta Q1 is greater than 0. When you say determine its sign, the next part of the question then asks you what is the significance of the positive utility, and basically when you say, or positive, I should say marginal utility here, the question says marginal utility. This is just a error in the writing on my end. So this should be positive marginal utility. Okay. And when you say mu is greater than 0, then what you're saying is that the utility is increasing monotonically with increases in Q1. So as Q1 is going up, U is going up, period. Now when you find the second derivative with respect to Q1, does this function display diminishing marginal utility? When you say delta U to U by delta Q1 square, you again start with this. So you go ahead with the division rule. Q1 minus gamma 1, V into derivative of U minus U into derivative of V upon V square. So, this is exactly what you would have here. I'm sorry. So that's precisely what you have here. And this means that, you basically have minus beta 1 upon Q1 minus gamma 1 square. Now again, beta 1 is greater than 0, Q1 minus gamma 1 is greater than 0. Anyway, it's a square term, so it has to be greater than 0. So the numerator is less than 0. Denominator is greater than 0, which means the fraction is less than 0. Which in there is a diminishing marginal utility holds, because if you'll recall, the second derivative will tell you the rate of change of the slope. In this case, the rate of change of mu. So basically what you know is that utility is increasing, but it is increasing at a decreasing rate as Q1 is increasing. Okay. Now another question that has been asked, not for this particular function in life, but in general as a question, is to calculate the MRS between X and Y. Now, this question essentially just requires you to remember the formula for MRS. The MRS between any two, goods for a utility function is basically the, marginal utility of one divided by the marginal utility other. So, you have MUX upon MUY. I've just calculated it, and MRS is basically MUX divided by MUY, which in this case is Y upon X. Now, given an isoquant k to the power 1 upon 6, L to the power 1 upon 2, you're supposed to find the slope of the isoquant. Again, you need to recall and you need to remember rather that the slope of the isoquant is given by dk upon dl, which is basically equal to mpl upon mpk. So to calculate dk by dl, you have delta q by delta k, which is mpk. You have mpl. The slope, which is the marginal rate of transformation, is mpl upon mpk. Again, if you calculate this, you come up with 3k by L. So the idea of both of these questions is just to be able to remember what the slope of the utility function, which in this case is the MRS, or what the slope of the isocon, which in this case is the MRT, is actually given by. So you just need to remember the formulas. Okay. Now another question that we have is, given the demand function q minus 90 plus 2p is equal to 0. So the next question that we come to is, given the demand function q minus 90 plus 2p is equal to 0 and the average cost function AC is equal to q square minus 39.5q plus 120 plus 125.q, you have to calculate the levels of output when the total revenue is maximum, the marginal cost is minimum, and the profits are maximum respectively. So this is just a maximization sort of problem. It's a problem very similar to the ones that you would discuss in unconstrained optimization. But like I said, all of the concepts in the following units are kind of intertwined with each other. So yeah, let's just look at how to solve it. Now you know that the demand function is given by this. The first thing and the first rule of any profit maximization or cost minimization exercise is that you always solve in terms of Q. You never ever solve in terms of P unless the question specifies it in a different sort of manner, or unless the question specifically asks you to, which it never will. So you have P is equal to 45 minus 0.5q. You have your TR, which you can write out P as P into Q, which you can write out. And after you've written your TR, you have to maximize your total revenue. So delta TR by delta Q has to be put to equal to 0. 45 minus Q is 0 and Q is equals to 45. Checking the second order condition, delta 2 TR by delta Q is going to be minus 1, which is less than 0, so you have a maximum. Okay. The second one is to minimize the cost. So you have given, question gives you your average cost. The first thing you need to do is to calculate the total cost, which is basically Q times the average cost. So you calculate TC. Then you have to minimize TC, so you do delta TC by delta Q, which is going to give you a marginal cost. And actually you have to minimize your MC. So the next thing is to obviously calculate the MC, which is basically the delta TC by delta Q, and you get the expression for the marginal cost, which is given by 3q square minus 79q plus 120. The next thing you do is minimize this, so delta MC by delta Q has to be equal to 0. So once you do that, you have Q is equal to 79 upon 6. Again, if you check the second order condition, delta 2 MC by delta Q square, it's going to be 6, which is greater than 0, which means that you have a minimum. Now the last one requires you to maximize your profits. Again, you do a TR minus TC. You have the profit function. You differentiate it, put it equal to 0, the first order condition. Once you do that, the two values of Q that you have are Q equals to 1 or Q equals to 25. Again, you have to test between these two. So the next thing you do is to calculate the second order condition, which in this case is 78 minus 6q. For Q equals to 1, this is going to be greater than 0, which means it would be a minima. For Q equals to 25, this would be less than 0, which means it would be a maxima. Therefore, profits would be maximized at Q equals 25. So that's it for this video. One thing that I've kind of forgotten here, and I should have possibly mentioned even before doing this, is that at each stage of this question you must calculate the level of Q and the level of profit. It's very important to calculate the level of profit because is rather not the profit, but whatever the objective function is. So if you were saying that let's say in this case total revenue is maximized at Q equals to 45, then you must calculate the value of total revenue at Q equals to 45. Similarly, you must calculate the value of marginal cost at its minimum. Similarly, profits at their maximum, whatever the value is, the value of the objective function at your extreme point has to be calculated by you at every stage of the question. Please do not forget this step. This step carries marks in every single question that you do of this type. So Yeah, that's just, my bad. I'm sorry. I should have remembered to, point this out earlier as well. Anyway, thank you.